Hello class and welcome to Unit 4 on Estimation and Hypothesis Testing. This is the portion of the course here where we're starting to delve more into the inference side of statistics and its usage in biostatistics. We will continue our discussion of estimation in this unit based on sample data. We will estimate population proportions, population means, and population variance, or standard deviation. These ideas of estimation will be applied to technology in the form of bootstrapping as well. Then we will move to the basic ideas of hypothesis testing and what it attempts to accomplish. And we will first look at specifically the basic forms of hypothesis testing involving a mean, a proportion, a mean, and a sample, and a standard deviation or variance. From this, we will examine testing claims about a population mean and variance, as I said. The objectives for this unit are to estimate the population proportion, mean, and standard deviation, or variance, based on sample data involving point estimates, sample size, and confidence intervals. Apply bootstrapping to confidence intervals when the requirements of our other methods are not satisfied. Write hypothesis statements and interpret the meaning. Describe and interpret the errors in hypothesis testing. And test claims about the proportion, mean, and standard deviation or variance with hypothesis testing. And then we have the links to the textbook. This is chapters 7 and 8 in the textbook. A bunch of optional reading, additional videos if you wish to look at it. And before I actually touch on the rest of this, I should probably note, I'll put this link inside of the announcement that you'll find this video in. But I came across, actually after having physically written all of this lovely stuff, I came across this lovely lesson plan, which is not a part of the course currently. But as we read what the discussion board here is going to start claiming different things. We have this this online lesson plan here on quantifying uncertainty, the p-value. Now, I mean, naturally, if you were to read this, you'll see that at the very end it includes stuff for example, teachers or professors to be connecting with their students and other instruction notes. But the instruction notes themselves, that's besides the point. This quantifying uncertainty, the p-value, this gives a lovely historical reference for why we use the p-value the way that we do. And the cool thing about it is the first couple of parts of here and are going over proofs. So like the proof by contradiction. So if you've taken the linear algebra class, not linear algebra, the discrete mathematics course before this, these proof topics should be relatively fresh in your mind. But proof by contradiction, we have a proof by the highly improbable. We don't go over that particular one in the course, but the same kind of ideas apply. And then we go through how proofs then are utilized when it comes to quantifying the p-value and whatnot. I even have a video that goes through some of those proof-based topics as well. But I feel like it's a nice little introduction kind of to the p-value and hypothesis testing in general, since it goes through, how do we get through back when, the whole idea of the hypothesis testing wasn't really quantified just yet, but they were kind of doing hypothesis testing then, just not in the formality that we currently have in. And you could see that this document goes through. I won't go through the entire document right now. But with that being said, the Unit 4 discussion board, hypothesis testing revolves around the terminology statistically significant to determine whether a claim is true. Many research journals use this as a benchmark to determine if the study should be published. Discuss the implications of determining which studies to publish on this criterion. And as you will see in my section, I think it was 8.1. Yeah, 8.1. Section 8.1, I have a slide dedicated to that. But I mean, as I said, this document here gives you a historical reference of the p-value and what it means. Is that helpful for that? Potentially. But statistically significant. Very important terms. And something that unfortunately the meaning does get misconstrued a lot. I have the data files connected in here. The Unit 4 problem set is on here, and I clicked on the wrong link, but you could go on there to submit it. Here we go. Here's the Unit 4 problem set. As you can see, there's 87 points on it. It goes through a whole bunch of questions involving confidence intervals and hypothesis tests, a little bit of bootstrapping, that type of thing. The Unit 4 Project 1, which we've talked about before, but that's going to be due at the end of this unit as well. If you have not already seen the document, this is the overview, requirements, and then of course the rubric that you can also find on Blackboard. There's also the Unit 4 test, due to the fact that we are roughly at the midpoint of this term. And as such, this is kind of like the midterm exam for it. Clicking on this, you see it's out of 114 points. You have until Sunday to complete it. And as you can see, this asks a whole variety of questions from Units 1, 2, and 3. And as you can guess by just looking at it, it asks a whole bunch of variety of questions that you will be able to see and then be able to answer those types of questions. And of course, you could click on here to actually upload that on Blackboard. But that's what we have here for Unit 4. Let me know if you have any questions or concerns. And since this will be posted on there for you to begin at the time of you watching this video, let me know if you have any questions or concerns. Thank you.